Good afternoon, everyone. Myself, Chandan B. I'm working as a physics lecturer, Magnur Basappa PU College, Davangere. Dear students, today I'm going to discuss just a few synopsis about the chapter is wave optics. The most important chapter, wave optics. Already you know that, already you studied in the class 11, that is waves chapter. So what is a mechanical waves, what is non-mechanical waves, what is transverse wave, what is longitudinal waves, and what are the displacement equations of waves? Different waves, progressive waves, stationary waves. There are different types of waves. So already you are studied in class 11. And what are the important parameters related to waves? Amplitude, frequency, wavelength, and phase. These are all important terms related to waves. So dear students, but the actual thing is, in a class 12, there is a concept like light and electromagnetic waves. So these are all related to waves concept. See, already you uh, ray optics and optical instrument chapter. Already you studied about light. What is light and what are the uses of light, convex and concave mirrors. So these are all studied in ray optics and optical instrument chapter. So now, in earlier days, one common confusion in all scientists, that is, light is wave nature or particle nature. This is a common confusion in all scientists. So in earlier days, the wave model, the first wave model given by Newton's, the first wave model, Newton corpuscular wave model. So this is the first theory, wave theory. That is, a corpuscle means light which consists of tiny particles. Light which consists of tiny particles. According to this theory, when light travels from a rarer medium to denser medium, according to this theory, light travels from denser medium to rarer medium. This is rarer medium, and this one is denser medium. When light travels from, this is normal. When light travels from rarer medium to denser medium, it bends towards normal. Means, according to Newton corpuscular wave theory, the speed of light in a denser medium greater than the speed of light in a rarer medium. So this is the uh, best first Newton's corpuscular wave theory given by Newton, and later in the year 1678, this is the contradiction concept. In the year 1678, the Dutch physicist Huygens, Christian Huygens, he successfully explained the concept of refraction and reflection when light travels from one medium to another medium. So, according to corpuscular wave theory, when light travels from rarer medium to denser medium, it bends towards the normal, means speed of light in denser medium is greater than the speed of light in rarer medium. But this is the contradiction theory of Newton corpuscular wave theory. And year 1678, the name of the scientist called Dutch physicist Christian Huygens successfully explained the phenomenon of refraction and reflection. All of you know that what is refraction and what is reflection. ಎಲ್ಲರಿಗೂ ಗೊತ್ತಿದೆ ನಿಮಗೆ refraction ಅಂದ್ರೇನು, reflection ಅಂದ್ರೇನು, ಕರೆಕ್ಟಾ? So next, according to Huygens theory, when light enters from rarer medium to denser medium, it bends towards the normal. It bends towards the normal. It means speed of light is greater, speed of light is greater in a rarer medium compared to denser, medium. So this is the statement, and this is the statement given by Huygens, and Huygens successfully explained wave theory of nature. So this is the in earlier days, all scientists have some confusions. Light waves as a wave nature or a particle nature. So this idea and this theory, wave theory given by Huygens, successfully explain refraction and reflection. Is it clear? So what next one is? Next one is after Huygens, wave theory. After next few years, wave theory can be explained by name of the scientist called Thomas Young. Thomas Young, the name of scientist, he successfully explained the phenomenon of wave theory of interference. Different phenomenons na explain ಮಾಡ್ತಾರೆ. That is first one is interference. And after 40 years, there are different types of different scientists performed different experiments and proves light waves as a wave nature. That is, and different phenomena like that: interference, diffraction, and polarizations. These phenomena explained light waves as a wave nature. Clear? So, next later on this chapter, wave optics, we will discuss light waves as a wave nature. What are the phenomena? First one is interference, second one is diffraction, third one is polarization. So we will discuss one by one. Today we will discuss about what is interference and what are the Young's double slit experiment given by Thomas Young, and what is the theory of interference, and what is Huygens principle, what are principles of Huygens, and what is the intensity of resultant waves. So this is all discussed today topic interference. Is it clear? So first one is Huygens. First one is wavefront. Just memorize all what are the synapses present in the wave optics. Just memorize. So just we later on we move on to the next few important numerical problems what previous year they asked. First one, wavefront. What is wavefront? Suppose the small light is there. That light spread all the disturbance in all the directions. That light acts as a source. Like just ಕಾಮ್ ಆಫ್ ವಾಟರ್ ಅಲ್ಲಿ ಜಸ್ಟ್ ನಾನು ವಾಟರ್ನ ಡ್ರಾಪ್ ಮಾಡಿದಾಗ ಯಾವ ತರ ವೇವ್ಸ್ ಡಿಸ್ಟರ್ಬೆನ್ಸ್ ಕ್ರಿಯೇಟ್ ಆಗುತ್ತೋ ದಟ್ ಡಿಸ್ಟರ್ಬೆನ್ಸ್ ಇಸ್ ಕಾಲ್ಡ್ ವೇವ್ ಫ್ರಂಟ್. That all the particles are vibrating at constant phase and constant wavelength. These are all called what? Wave front. But suppose different bulbs are there. That if we switch on that bulb, that light produces all that light produces disturbance around the source. That disturbance, a particle vibrates in a different constant phase. It's called wavefront. And what is a wavefront? It is a locus of a point. It's a locus of a point at constant phase. It's a locus of a point at constant phase. The most important word, it's a locus of a point at constant phase. So later on we come into phase concept. First, what is wavefront? It is a locus of a point at constant phase. And what are the different types of wavefront? The most important topic. What are the different types of wavefront? Different types of wavefront. First one is first one is spherical wavefront. First one is spherical wavefront. First one is spherical wavefront. Second one is cylindrical wavefront. Third one is plane wavefront. The shape of the wavefront is depends upon shape of a source. Nothing but different wavefronts are there. First one is spherical wavefront, second one is cylindrical wavefront, third one is plane wavefront. So what is a cylindrical, what is a spherical, and what is a plane wavefront? So most important question. First one, what is a spherical wavefront? What is a spherical wavefront? It is a wavefront of it is a wavefront of point source. It is a wavefront of point source at finite distance. A finite distance. Nothing but example, ನಮ್ಮ ಕ್ಲಾಸ್ ರೂಮ್ ಅಲ್ಲಿ ಬಲ್ಬ್ ಇರ್ತಾವಲ್ಲ, LED bulbs. That is the example of a spherical wave. That bulb produces all spherical wavefront around the surroundings. That bulb produces a disturbance around the surroundings. That is called a spherical wavefront. Then what is a cylindrical wavefront? So most important word is point source at finite distance. Point source at finite distance. And what is a cylindrical wavefront? It is a wavefront of linear source. Linear source at finite distance. Linear source at finite distance. Finite distance. Linear source at finite distance. And last, what is a plane wavefront? It's a point or a linear source. Point source ಆಗ್ಬೋದು ಅಥವಾ linear source ಆಗ್ಬೋದು, but at infinite distance. So near the source or near the bulb, that wavefront is either spherical or cylindrical. If it is spherical, at finite distance, near the bulb or near the source, the wavefront is spherical. But that wavefront moves forward direction at infinite distance. That wavefront is plane wavefront. So just what is the plane wavefront? Point or linear? Point or linear at infinite distance. At infinite distance. So the most important word, point or infinite distance. It's a point source or finite distance, and a linear source at a finite distance. So plane wavefront, point or linear at infinite distance. The most important word is CET-nalli keltare. So this is about wavefronts. So then give an example of wavefronts. So listen, what is a spherical wavefront? So what is a spherical wavefront? Example of spherical wavefront. Example of spherical wavefront. Like just this is a source, it produces spherical wavefront. The rays perpendicular to the wavefront. So this is spherical wavefront. Or linear. Linear wave. So this is linear. What linear source at finite distance. What is a plane wavefront? What is a plane wavefront? So these are the examples of spherical wavefront, cylindrical wavefront, and plane wavefront. Understood? So now the most important question is, what are the principles of Huygens? What is the principle of Huygens principle? Huygens principle. So most important Huygens principle. See, already we know that. First point is, every point on the wavefront is a source of secondary wavelets. And these wavelets spread out in all direction with the speed of the wave. So just this is a point source or a spherical wavefront. This wavefront spread out in all direction with the speed of the wave. And these wavelets produces secondary wavelets. These secondary wavelets spread out in all the direction. This is the principle of Huygens. And second one, the tangent drawn on the secondary wavelets produces new wavelets. See, this one is, see, the tangent drawn on the secondary wavelets produces a new wavefront. Every point and a tangent drawn on the wavelet, just like it moves like this at infinite distance. At infinite distance, the wavefront, spherical wavefront becomes a plane wavefront. So near the source or near the bulb, the wavefront becomes spherical. As we move forward, the wavefront becomes plane. So this is the Huygens principle. So what is the Huygens principle? Already just memorize ಮಾಡ್ತಾ ಇದೀನಿ. So what is the Huygens principle? Every point on the wavefront is a source of secondary wavelets. And these secondary wavelets are spread out in all the direction. That is the Huygens principle. And the second one is the tangent drawn on the secondary wavelets. The tangent drawn on the secondary wavelets gives produces new wavelets. That is called Huygens principle. So next one is, we move on to the next one is, so next one is Huygens principle over. What next? Draw shape of refracted or reflected wavefront. Draw shape of refracted and or reflected wavefront when plane wavefront is incident on first one is prism. So listen, so this is prism. When wavefront is incident on the prism, so prism has, this is A and this is B. The wavefront AB, the upper part of A moves very smaller thickness, and lower part B, it moves larger thickness, and and comes out of just a plane wavefront. Is it clear? And the next, the second one, convex lens. Second one is convex lens. See, this is convex lens. Upper and the lower part of the convex lens has very small thickness, but the middle portion of the lens has large thickness. Wavefront, plane wavefront moves and incident on the convex lens, and it reaches, and out of the convex lens, a plane wavefront becomes spherical wavefront. What is the shape of a refracted or reflected wavefront when the plane wavefront incident on? First one is a prism, second one is a convex lens, third one is a concave mirror, and third one is a convex mirror. So different types of prisms, convex lens, ನಾವೆಲ್ಲವನ್ನೂ ಕೂಡ ಇನ್ಸಿಡೆಂಟ್ ಮಾಡ್ತಾ ಹೋದ್ರೆ what is the output, what is the shape of the refracted or reflected wavefronts. If we incident a plane wavefront on the prism, so output wavefront is also same plane wavefront. But when plane wavefront is incident on the convex lens, the upper part of the lens, it moves very less thickness, and the lower part of it moves very large thickness, and output is spherical wavefront. And output is spherical wavefront. So next one is third one is concave mirror. Third one is concave mirror. Say first one, concave mirror. So when a plane wavefront incident on the concave mirror, it diverges. Sorry, it converges at F. And a reflected wavefront is also spherical wavefront. Reflected wavefront is a spherical wavefront. And the last one is fourth one, convex. And fourth one is convex mirror. So if incident of plane wavefront and it diverges and it appears to, that is also spherical wavefront. So these are the different shape of the refracted or reflected wavefront when a plane wavefront incident on prism, convex lens, concave lens, and convex mirror and a concave mirror. Is it clear? So the most important thing is this is about ಇಷ್ಟೊತ್ತು ನಾನು ಏನು ಎಕ್ಸ್ಪ್ಲೇನ್ ಮಾಡಿದೆ ಅದೆಲ್ಲದೂ ಕೂಡ ಬೇಸಿಕ್ ಕಾನ್ಸೆಪ್ಟ್. What is eigens? What are the principle of eigens? And what is a wavefront? What are the different types of wavefronts? And the most important topic is now most important ಕಾಂಪಿಟೇಟಿವ್ ಕ್ವಶನ್ಸ್ ಇದರಲ್ಲಿ ಕೇಳುವಂಥದ್ದು. So next one is what is phase? So ನಿಮಗೆ ಆಲ್ರೆಡಿ ಇದ್ರ ಬಗ್ಗೆ ಐಡಿಯಾ ಇದೆ. What is a phase? It's a different first one, path difference. It's a what is wavefront? What is phase? It is a state of vibration of a particle. It's a state of vibration of a particle. And path difference. What is path difference? And also what is second one now? Phase difference. Second one is phase difference. Path difference denoted by symbol delta x, and phase difference denoted by symbol delta phi. So what is the relation between delta x and delta phi? Delta phi equals 2 pi by lambda. Most important formula. What is the phase difference between path difference? What is the relation between phase difference and path difference? That is delta phi equals 2 pi by lambda into delta x. And most important concept and most important word in wave optic chapter. What is wavefront? It's a locus of a points of constant phase. But the source produces a disturbance in a surrounding medium. It produces a constant phase. At constant phase difference, ಏನು ಸುತ್ತಲೂ ಕೂಡ ಏನು ವೇವ್ ಫ್ರಂಟ್ ಡಿಸ್ಟರ್ಬೆನ್ಸ್ ನ ಪ್ರೊಡ್ಯೂಸ್ ಮಾಡ್ಕೊಳ್ತಾ ಹೋಗುತ್ತಲ್ಲ, ದಟ್ ಈಸ್ ಅಟ್ ಕಾನ್ಸ್ಟೆಂಟ್ ಫೇಸ್ ಡಿಫರೆನ್ಸ್. It's a surface of a constant phase that is called a wave front. And the most important that word phase difference and path difference. What is the relation between phase difference and path difference? Delta phi equals 2 pi by lambda into delta x. That is a phase difference and a path difference. And the next one is superposition principle. Next one is superposition principle. If two waves, nothing but what is the displacement equation? Y1 equals a sine omega t minus kx plus phi. So this is a means amplitude, omega means angular frequency, k means angular wave number, and what is the phi means phase. So this is the displacement equation of wave. If two waves are superposed on each other, if two waves, if two waves are superposed on each other, superposed on each other, superposed on each other, then resultant displacement is y equals y1 plus y2. So this is the superposition principle of two waves. Is it clear? So next, what is intensity? Intensity of wave. Intensity of wave. It is, what is the definition of intensity of plane wave? It is the wave energy. It's the wave energy passing. It's the wave energy passing normally across per unit area, across per unit area per unit second. Per unit second. So this is the intensity of plane wave. It is the intensity of plane wave. What is it is the wave energy passing normally across per unit area per unit second. So what is the expression for intensity of wave? What is the expression for intensity of wave? 2 pi square f square a square rho v. That is, I is directly proportional to what? A square. The most important thing is intensity of wave is directly proportional to amplitude square, where A is called amplitude. Is it clear? So, what Huygens principle completed, and what are the different shape of reflected and refraction wavefront, different object completed, and the next two most important intensity of plane wave. So I equals 2 pi square f square a square rho into v. That is what I is directly proportional to a square. Is it clear? So then this is what about phase? Phase can be represented by different. So there is a degree, radian. But this is plus a, and this one is minus a. This is 0, t by 4, t by 2, 3t by 4, then t, or 0, pi by 2, pi, 3 pi by 2, and 2 pi. So if in radian, pi by 2 pi, 3 pi by 2, and 2 pi, these are all phases. What is a phase? It's a state of vibration of a particle. It's called phases. So this is the general information about intensity of a wave and a phase, wavefront, and what are the principle of what are the Huygens principle, and what is about concept of wavelets. The shape of a wavefront is depends upon the shape of a source. Is it clear? So now the most important question is, next one is it clear? So next one is theory of interference. Next one is theory of interference. Theory of interference. If two waves, for examples, classroom ಅಲ್ಲಿ ಆಗಿರ್ಬೋದು ಅಥವಾ ನಿಮ್ಮ ಮನೇಲಿ ಆಗಿರ್ಬೋದು, two light waves ಎರಡು ಒಂದಕ್ಕೊಂದು ಸೂಪರ್ಪೋಸ್ ಆಗ್ತಾ ಇದೆ. But light waves superposed on nature, that is according to superposition principle, y equals y1 plus y2. So then if y1 equals a sine omega t plus and y2 displacement equation for second, a equals sine omega t plus 5, omega t plus 5 of same amplitude. Theory of interference. If two waves are if two waves having same amplitude are superposed on each other, then what is the displacement equation of first wave? Y1 equals a sin omega t and y2 equals a sin of omega t plus phi. Then according to superposition principle, then equation number 1, according to superposition principle, y equals y1 plus y2. Y equals y1 plus y2. Then y equals y1 means a sin omega t plus a sin of omega t plus phi. ಸೊ ಆಲ್ರೆಡಿ ನೀವು ಥಿಯರಿನಲ್ಲಿ ಇದನ್ನ ಓದಿದ್ದೀರಾ ಮತ್ತು ನಾನು ಕಂಪ್ಲೀಟ್ ಡೆರಿವೇಶನ್ಸ್ ಎಲ್ಲ ಮಾಡ್ಕೊಳ್ತಾ ಹೋಗಲ್ಲ, ಜಸ್ಟ್ ಡೈರೆಕ್ಟರ್ ವಾಟ್ ಇಸ್ ದ ರಿಸಲ್ಟೆಂಟ್ y equals y1 plus y2 a sin omega t plus a sin of omega t plus what is the resultant wave, that is y equals r equals that is y equals r sin of omega t plus phi by 2. This is the resultant wave equation. If two waves are superposed here, this one waves and this one, these two waves are superposed on each other, but same amplitude, where A represents amplitude. See then, where R equals, then where R equals 2A cos phi by 2. So this is the resultant amplitude of two waves. This is the displacement equation for first wave, and this is the displacement equation for second wave. And according to superposition principle, y equals y1 plus y2. Next, y equals a sin omega t plus a sin of omega t plus phi. ಇದನ್ನ ನಾವು ಸಾಲ್ವ್ ಮಾಡ್ಕೊಳ್ತಾ ಬಂದ್ರೆ what is the resultant displacement equation of the two waves are superposed wave, that is r sin omega t plus phi by 2. Is it clear? Where most important, where r equals 2a cos phi by 2. 2a cos phi by 2. Keep in mind, I is directly proportional to what? A square. Keep in mind, I is directly proportional to a square. Next, where r equals 2a cos phi by 2. First condition, what is the constructive interference? First condition, constructive interference. Constructive interference. First one is constructive interference. So what is constructive interference? If two waves, crest of one wave falls on crest of another wave. What is destructive interference? Crest of one wave falls on a trough of another wave. That is a constructive or a destructive interference. See, first one, constructive interference. What is the phase difference? 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 Delta phi equals 2 pi n. Phase difference. And path difference equals n lambda. This is constructive interference. Phase difference equals delta phi equals 2 pi n and path difference in lambda. And second one is destructive interference. Second one is destructive interference. So what is the phase difference? What is the phase difference? What is the phase difference? 2n plus 1 by what is the path difference? Path difference 2n plus 1 lambda by 2. So this is the path difference and the phase difference of constructive and destructive interference. The most important questions, theory of interference. And ಇದರಲ್ಲಿ ನಿಮಗೆ CET questions ಬರೋದು. ಈಗ ನೆಕ್ಸ್ಟ್ ಏನು ನಾನು ಫಾರ್ಮುಲಾಸ್ಗಳನ್ನ ಬರಿತಾ ಹೋಗ್ತೀನಿ, ಅದನ್ನ ನೀಟಾಗಿ ನೋಟ್ ಡೌನ್ ಮಾಡ್ಕೊಳ್ತಾ ಹೋಗಿ. ಸೊ ದ ಮೋಸ್ಟ್ ಇಂಪಾರ್ಟೆಂಟ್ ಫಾರ್ಮುಲಾಸ್, ಇಂಟೆನ್ಸಿಟಿ, ರಿಸಲ್ಟೆಂಟ್ ಆಂಪ್ಲಿಟ್ಯೂಡ್ ಮೇಲೆ ಯಾವ ತರ ಫಾರ್ಮುಲಾ ಬರುತ್ತೆ, ರಿಸಲ್ಟೆಂಟ್ ಇಂಟೆನ್ಸಿಟಿ ಯಾವ ತರ ಯಾವ ಫಾರ್ಮುಲಾ ಬರುತ್ತೆ, what is the maximum intensity and what is the minimum intensity and what is the intensity of resultant wave, ಇದು ಎಲ್ಲ ಫಾರ್ಮುಲಾಸ್ ಗಳು ಬರ್ತಾ ಹೋಗ್ತವೆ. So this is theory of interference. The next one is So next one is, we know that intensity is directly proportional to what? A square. Intensity is directly proportional to a square. So now ಇಷ್ಟೊತ್ತವರೆಗೂ ನೋಡಿದ್ದು ನಿಮಗೆ resultant if two waves having same amplitude superposed on each other, the resulting wave pattern is y equals y1 plus y2 ಅಂತ ತಗೊಳ್ತೀವಿ. And a resultant if same amplitude, resultant amplitude is 2a cos phi by 2. 2a cos phi by 2 resultant amplitude. But we know that this is R is called resultant amplitude of R is called resultant amplitude. But R is called resultant amplitude. Then again we know that I is directly proportional to a square. That is I equals a means, then what, this is also resultant amplitude 2a cos phi by 2 whole square. Then I equals 4a square cos square phi by 2, 4a square cos square phi by 2. Then I equals 4a square, nothing but we can, this one as a square can be written as I naught. I naught means maximum intensity. This is the formula used to calculate the resultant intensity of resultant wave. So first thing is intensity is directly proportional to a square. Resultant amplitude is 2a cos phi by 2. Resultant amplitude ಸಿಕ್ತು, then resultant intensity calculate ಮಾಡಕ್ಕೆ ಒಂದು formula ಬೇಕು. Then I is directly proportional to R square, that is amplitude square. Amplitude is 2a cos phi by 2 whole square. I equals 4a square cos square phi by 2. So this is the formula to calculate intensity of resultant wave. So I equals, what is the formula of intensity of resultant wave? I equals 4 I naught cos square phi by 2. So next one is if two waves of different amplitude, there is a1 and a2. If two waves of different amplitudes a1 a2 are superposed, then resultant amplitude is AR equals square root of a1 square plus a2 square plus 2 a1 a2 cos phi. a1 square plus a2 square plus 2 a1 a2 cos phi. Two waves of different amplitude I1 and I2 are superposed, then resultant amplitude can be calculated by using the formula square root of a1 square plus a2 square plus 2a1 a2 cos phi. And next, in terms of intensity, we can write this one as, I equals, that is a square equals a1 square plus a2 square plus 2a1 a2 cos phi. So already we know that I is directly proportional to a square. Then intensity I equals, if different amplitudes, I equals I1 plus I2 plus 2 into square root of I1 I2 cos phi. Square root of I1 I2 cos phi. So this is the formula to calculate what? Intensity of two waves. So this is the formula of resultant amplitude, and this is the formula of intensity. Is it clear? And now next one is A maximum. Formulas ಎಲ್ಲ ಬರ್ಕೊಂಡಿದ್ದಾಯ್ತಾ? Next one is I maximum. So just once again I'll square it off. I1 plus I2 plus 2 into square root of I1 I2 cos phi, and intensity of resultant wave 4 I naught cos square phi by 2, or 4 or I maximum into cos square phi by 2. ಇದ್ರ ಮೇಲ್ಗಡೆ ತುಂಬಾ ಕ್ವಶನ್ಸ್ ಗಳನ್ನ ಕೇಳ್ತಾ ಇದ್ದಾರೆ. ಡೆನ್ಸಿಟಿ ಆಫ್ ಟೂ ವೇವ್ಸ್ ತುಂಬಾ ಕ್ವಶನ್ಸ್ ಗಳನ್ನ ಕೇಳ್ತಾ ಇದ್ದಾರೆ. ನೆಕ್ಸ್ಟ್ ಐ ಮ್ಯಾಕ್ಸಿಮಮ್, I maximum because A1 plus A2 whole square. You have to find out what is the maximum intensity, A1 plus A2 whole square, or root I1 plus root I2 whole square. And next I minimum A1 minus A2 whole square plus root I1 minus root I2 whole square. This is I maximum and I minimum. And one more formula, most important, I maximum divided by I minimum. I maximum divided by I minimum, that is ratio of A1 plus A2 whole square and A1 minus A2 whole square. In terms of intensity, square root of I1 plus square root of I2 whole square divided by square root of I1 minus square root of I2 whole square. Is it clear? ಸೊ ಮೋಸ್ಟ್ ಇಂಪಾರ್ಟೆಂಟ್ ಕ್ವಶನ್ಸ್ ನ ಇದ್ರ ಮೇಲ್ಗಡೆ ಕೇಳ್ಕೊಳ್ತಾ ಬಂದಿದ್ದಾರೆ. ಇದನ್ನ ನೀಟಾಗಿ ಫಾರ್ಮುಲಾಸ್ಗಳನ್ನ ವರ್ಕ್ ಮಾಡ್ಕೊಳ್ತಾ ಹೋಗಿ, ಚೆನ್ನಾಗಿ ಬಯಟ್ ಮಾಡ್ಕೊಳ್ತಾ ಹೋಗಿ, ಈಸಿಯಾಗಿ ಫಾರ್ಮುಲಾಸ್ಗಳು ನೆನಪಿರ್ತವೆ. ಇದ್ರ ಮೇಲೆ ಕ್ವಶನ್ಸ್ಗಳನ್ನ ಈಸಿಯಾಗಿ ಸಾಲ್ವ್ ಮಾಡ್ಕೋಬಹುದು. ಮೋಸ್ಟ್ ಆಫ್ ಆಲ್ ನಿಮ್ಮ ಕಾಂಪಿಟೇಟಿವ್ ಕ್ವಶನ್ಸ್ಗಳೆಲ್ಲ ಇದ್ರ ಮೇಲ್ಗಡೆ ಥಿಯರಿ ಆಫ್ ಇಂಟರ್ಫರೆನ್ಸ್ ರಿಲೇಟೆಡ್ ಬಂದ್ರೆ ಇದೇ ಫಾರ್ಮುಲಾಸ್ ಮೇಲ್ಗಡೆ ಕ್ವಶನ್ಸ್ಗಳನ್ನ ಕೇಳ್ಕೊಳ್ತಾ ಬರ್ತಿದ್ದಾರೆ. ಇಸ್ ಇಟ್ ಕ್ಲಿಯರ್? ಸೊ ನೆಕ್ಸ್ಟ್ ಒನ್ ಇಸ್, so this is the formula of intensity and maximum and minimum, and ratio of maximum and minimum, that is a formula, and also I is directly proportional to. Next one is I is directly proportional to what? A square, and also directly proportional to slit width, that is in Young's double slit experiment ಅಲ್ಲಿ ಬರ್ತಿದ್ದೀನಿ. ಡಿಫ್ರೆಂಟ್ ಟೈಪ್ಸ್ ಆಫ್ ಫ್ರಿಂಜಸ್ ಫಾರ್ಮೇಶನ್ ಆಗ್ತಾ ಹೋದಾಗ, that is intensity is directly proportional to A square and also directly proportional to slit width. Is it clear? So next one is Young's double slit experiment. Next one is most important concept, Young's double slit experiment. Most important. ನಮ್ಮ ಕಾಂಪಿಟೇಟಿವ್ ಪ್ರೀವಿಯಸ್ ಇಯರ್ ಎಲ್ಲಾ ಕ್ವಶನ್ಸ್ಗಳನ್ನ ತೆಗೆದು ನೋಡಿದಾಗ ಮೋಸ್ಟ್ ಆಫ್ ದ ಕ್ವಶನ್ಸ್ ಕೇಳಿರೋದೆ ಈ ಯಂಗ್ಸ್ ಡಬಲ್ ಸ್ಲಿಟ್ ಎಕ್ಸ್ಪೆರಿಮೆಂಟ್ ಮೇಲೆನೆ. ಸೊ ಫಸ್ಟ್ ಕಾನ್ಸೆಪ್ಟ್ ನ ನೀಟಾಗಿ ನೀವು ಅರ್ಥ ಮಾಡ್ಕೊಳ್ರಿ. ದೆನ್ ಯಾವ ತರ ಕ್ವಶನ್ಸ್ಗಳನ್ನ ಸಾಲ್ವ್ ಮಾಡಬೇಕು ಅನ್ನೋದು ನೆಕ್ಸ್ಟ್ ಕ್ವಶನ್ಸ್ ಬಂದಾಗ ನಾನು ಹೇಳ್ತೀನಿ. ಫಸ್ಟ್ ಒನ್, ಯಂಗ್ಸ್ ಡಬಲ್ ಸ್ಲಿಟ್ experiment. In the year 1801, the name of the scientist called Thomas Young successfully explained the interference pattern. Nothing but alternate bright dark fringes. How alternate bright and dark fringes are formed? What is the width of fringe width? And next, what is the distance between alternate and bright dark fringes? Is it clear? And what is the condition for a sustained interference pattern? And most important, before going to explain a Young's double slit experiment, first one, what is a coherent source? What is coherent source? Next one is incoherent source. First one is coherent source, second one is incoherent. What is coherent source? What is coherent source? ಒಂದ್ಸರಿ ಇದನ್ನ CET ಕ್ವಶನ್ಸ್ ಅಲ್ಲಿ ಕೇಳಿದ್ದಾರೆ. What is the coherent source? It is a source. It is a source which emits light of same wavelength but and constant phase difference. The most important word, constant phase difference. Most important word, constant phase difference. So what is coherent source? It is a source which emits light of same wavelength and constant phase difference. So next one is what is a coherent source? What is incoherent source? It is a source which emits light of it is a source it is a source which 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 emits light of different wavelength, different wavelength and different phase difference and different phase difference. What is a coherent source? What is a coherent source? It is a source which emits light of same wavelength at constant phase difference. It is a source which emits light of different wavelength at different phase difference. The most important concept, coherent source. ಆಪ್ಷನ್ಸ್ ಅಲ್ಲಿ ಕೇಳಿರ್ತಾರೆ. ಕೋರೆಂಟ್ ಸೋರ್ಸ್ ಅಂದ್ರೆ ಕಾನ್ಸ್ಟೆಂಟ್ ಫೇಸ್ ಡಿಫರೆನ್ಸ್ ಇರಬೇಕು. ಇನ್ಕೋರೆಂಟ್ ಸೋರ್ಸ್ ಅಂದ್ರೆ ಡಿಫ್ರೆಂಟ್ ಫೇಸ್ ಡಿಫರೆನ್ಸ್ ಇರಬೇಕು. ಅವನ್ನ ಕೋರೆಂಟ್ ಸೋರ್ಸ್ ಅಂಡ್ ಇನ್ಕೋರೆಂಟ್ ಸೋರ್ಸ್ ಅಂತ ಕರಿತೀವಿ. ಅಂಡ್ ನೆಕ್ಸ್ಟ್ ವಿ ಮೂವ್ ಆನ್ ಟು ದಿ ಕಾನ್ಸೆಪ್ಟ್ ದಟ್ ಈಸ್ Young's double slit experiment. Most important Young's double slit experiment. Young's double slit experiment. Young's double slit experiment. See, there's two ways. This is a source. This source produces a coherent source, and this one is a screen. Alternate bright dark fringes are observed. Alternate bright dark fringes are observed. Nothing but crust of one wave falls on a trough of another wave. That is, dark fringes are observed. In the middle, central maximum, always bright fringes will be produced. Always bright fringes. And this one is dark fringes. Like this, alternate dark, bright fringes are observed. What are the characteristics of Young's double slit experiment? Already ನೀವು ಕ್ಲಾಸಸ್ ಅಲ್ಲೆಲ್ಲ ಸ್ಟಡಿ ಮಾಡಿದಿರ. ಜಸ್ಟ್ ನಾನು ಸಿನಾಪ್ಸಿಸ್ ನ ಮೆಮೊರೈಸ್ ಮಾಡ್ಕೊಳ್ತಾ ಹೋಗ್ತಾ ಇದ್ದೀನಿ, ಬಿಕಾಸ್ ಪ್ರಾಬ್ಲಮ್ಸ್ ನ ಸಾಲ್ವ್ ಮಾಡೋದು ತುಂಬಾ ಇಂಪಾರ್ಟೆಂಟ್. ಜಸ್ಟ್ ಸಿನಾಪ್ಸಿಸ್ ನ ಮೆಮೊರೈಸ್ ಮಾಡ್ಕೊಳ್ತಾ ಹೋಗೋಣ. ಸೊ ದಿಸ್ ಇಸ್ central maxima, nothing but central always bright fringes is formed, and alternate bright dark fringes are observed, and some distance and equal intensity of from a central maxima, alternate intensity, equal intensity from central maxima. Equal intensity. What are the characteristics of this Young's double slit experiment? First one is alternate dark and bright fringes are observed. Second one is the intensity of the bright fringes is constant. And the third one is intensity of dark fringes is 0, and distance between alternate dark and bright fringes are same. So this is Young's double slit experiment. And what is the expression for distance of nth bright fringe? So this is the main important concept. Xn equals n lambda d by d. And second one is n plus 1, that is n plus 1 lambda d by d, and bright fringe is fringe width, that is fringe width beta equals beta equals beta equals lambda d by d. What is the expression for a fringe width? Beta equals lambda d by d. So ನಿಮಗೆ questions ಕೇಳ್ತಾರೆ. For a bright fringe, for a bright fringe, for bright fringe, what is the formula? N lambda d by d. For a dark fringe, for a dark fringe, 2n plus 2n minus 1 lambda d divided by 2d. 2n minus 1 lambda d divided by 2d. ನಿಮ್ಗೆ ಕೆಲವೊಂದು ಬುಕ್ಕಲ್ಲಿ 2n plus 1 lambda d by 2d ಅಂತಾನು ಕೊಟ್ಟಿದ್ದಾರೆ. ಬಟ್ ಪ್ಲಸ್ ತಗೊಂಡ್ರೆ ನಾವು n ಗೆ ಒಂದು ವ್ಯಾಲ್ಯೂಸ್ ನ ಕಡಿಮೆ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡಬೇಕು. ಬಟ್ 2n minus 1 ತಗೊಂಡ್ರೆ ಅಂದ್ರೆ n ಗೆ ಯಾವ ವ್ಯಾಲ್ಯೂಸ್ ಕೊಟ್ಟಿರ್ತಾನ, ಫಿಫ್ತ್ ಡಾರ್ಕ್ ಫ್ರಿಂಜ್, ಸೆವೆಂತ್ ಡಾರ್ಕ್ ಫ್ರಿಂಜ್ ಕೊಟ್ಟಿದ್ರೆ ಜಸ್ಟ್ ಅದೇ ವ್ಯಾಲ್ಯೂಸ್ ನ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡ್ಕೊಂಡ್ರೆ ಆಯ್ತು. ಕರೆಕ್ಟಾ? ಸೊ ದಿಸ್ ಇಸ್ ದ ಫಾರ್ಮುಲಾ ಆಫ್ beta equals lambda d divided by d, and for bright fringe n lambda divided by d, and for dark fringe 2n minus 1 lambda d by 2d. See, one thing that if splits of if any transparent medium just like mica or any transparent medium is of refractive index mu is incident on path of a beam. ಯಾವುದೋ ಒಂದು ಟ್ರಾನ್ಸ್ಪರೆಂಟ್ ಮೀಡಿಯಂ ನ ನಾನು ಈ ಪಾತ್ ಅಲ್ಲಿ ಇನ್ಸಿಡೆಂಟ್ ಮಾಡಿದ್ರೆ ದ ರಿಸಲ್ಟೆಂಟ್ interference pattern gets shifted. Interference pattern gets shifted, but keep in mind, the interference pattern gets shifted, but fringe width unaffected. But fringe width is unaffected. ಯಾವುದೋ ಒಂದು two slits ಇದೆ. So this is the distance between so this is the distance between this is the distance between small d is slit width and capital D is distance between slit width and strain. So what is the expression for fringe width? Beta equals lambda d by d, and most important question is what is the lateral shift? What is the lateral shift? Nothing but when a transparent medium just like mica is incident on any path of the light of refractive index mu is incident on any path of the light, the interference pattern gets shifted, but fringe width is unaffected. Fringe width ಎಷ್ಟಿರುತ್ತೋ ಅಷ್ಟೇ ಇರುತ್ತೆ, ಬಟ್ ಪ್ಯಾಟ್ರನ್ ಶಿಫ್ಟ್ ಆಗುತ್ತೆ. ಎಷ್ಟು ಶಿಫ್ಟ್ ಆಗುತ್ತೆ ಅದನ್ನ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡೋಕೆ ಫಾರ್ಮುಲಾ ಏನು? ದಟ್ ಈಸ್ LS. This LS equals mu minus 1 TD, that is LS equals mu minus 1 T D divided by D. So previous year ಈ ಫಾರ್ಮುಲಾದ ಮೇಲೆ ಕ್ವಶನ್ಸ್ ನ ಕೇಳಿದ್ದಾರೆ. ಅಂಡ್ ಬೀಟಾ ಈಕ್ವಲ್ಸ್ ಲ್ಯಾಂಬ್ಡಾ ಡಿ ಬೈ ಡಿ ಈ ಫಾರ್ಮುಲಾದ ಮೇಲೆ ಕ್ವಶನ್ಸ್ ಕೇಳಿದ್ದಾರೆ, ಇದ್ರ ಮೇಲ್ಗಡೆ ಕೇಳಿದ್ದಾರೆ. Is it clear? So and what is the angular position? And what is the angular position? And angular position. What is angular position? That is sin theta equals lambda by d. ಇದು ಫಾರ್ಮುಲಾ ಮೇಲೆ ಕ್ವಶನ್ಸ್ ನ ಕೇಳಿದ್ದಾರೆ. Young's double slit experiment. Is it clear? Understood all of you? So Huygens principle and intensity of interference pattern and intensity of superposition waves and resultant amplitude and I maximum and I minimum and I is directly proportional to a square. ಇದ್ರ ಮೇಲೆ ಎಲ್ಲಾನು ಕೂಡ ಕ್ವಶನ್ಸ್ ನ ಕೇಳ್ಕೊಳ್ತಾ ಹೋಗಿದ್ದಾರೆ. See, between these two slits ಬಿಟ್ವೀನ್ ದೀಸ್ ಟೂ ಸ್ಲಿಟ್ಸ್ ಇನ್ನೊಂದು ಸ್ಲಿಟ್ ಅನ್ನ ನಾನು ಇನ್ಸರ್ಟ್ ಮಾಡಿದೆ ಅಂದ್ರೆ ಅದ್ರ ಕಾಂಟ್ರಾಸ್ಟ್, ಈ ಇಂಟರ್ಫರೆನ್ಸ್ ಪ್ಯಾಟ್ರನ್ ಕಾಂಟ್ರಾಸ್ಟ್ ಏನಾಗುತ್ತೆ, ಡಿಕ್ರೀಸ್ ಆಗ್ತಾ ಹೋಗುತ್ತೆ. ಕ್ಲಿಯರ್? ಸಿ ಐಗನ್ಸ್ ಏನ್ ಮಾಡ್ದ, ಜಸ್ಟ್ ಸೆಕೆಂಡರಿ ವೇವ್ಲೆಟ್ಸ್ ಸ್ಟ್ರಾಂಗ್ಲಿ ಆರ್ಗ್ಯೂಡ್ ದಟ್. ಐಗನ್ ಸ್ಟ್ರಾಂಗ್ ಆಗಿ ಆರ್ಗ್ಯೂ ಮಾಡ್ಕೊಳ್ತಾ ಹೋಗ್ತಾನೆ. ಏನಂತ ಆರ್ಗ್ಯೂ ಮಾಡ್ಕೊಳ್ತಾ ಹೋಗ್ತಾನೆ? ಸಿ the forward amplitude of the forward wavelets as maximum compared to back wavefront. ಫಾರ್ವರ್ಡ್ ವೇವ್ ಫ್ರಂಟ್ಸ್ ಏನಿರ್ತವೆ ಅದರದ್ದು ಆಂಪ್ಲಿಟ್ಯೂಡ್ ಮ್ಯಾಕ್ಸಿಮಮ್ ಆಗ್ತಾ ಹೋಗುತ್ತೆ, ಬಟ್ ಬ್ಯಾಕ್ ವೇವ್ ಫ್ರಂಟ್ ಆಂಪ್ಲಿಟ್ಯೂಡ್ 0 ಆಗುತ್ತೆ ಅಂತ ಸ್ಟ್ರಾಂಗ್ ಆಗಿ ಆರ್ಗ್ಯೂ ಮಾಡ್ಕೊಳ್ತಾ ಹೋಗ್ತಾನೆ. ಸೊ ಅದನ್ನ ಪ್ರೂವ್ ಕೂಡ ಮಾಡ್ತಾರೆ. ಸೊ ಓಕೆ, ದಿಸ್ ಇಸ್ ದ ಯಂಗ್ಸ್ ಡಬಲ್ ಸ್ಲಿಟ್ ಎಕ್ಸ್ಪೆರಿಮೆಂಟ್ ಅಂಡ್ ದಿಸ್ ಇಸ್ ದ once again I write all the formulas. So just keep in mind, once all the first one is resultant amplitude. First one is resultant amplitude. Resultant amplitude, that is 2a cos phi by 2. And resultant intensity I equals 4 I naught. I equals 4 I naught cos square by 5 by 2. And next one is I equals square root of, that is I1 plus I2 plus 2 into square root of I1 I2 cos 5. And resultant amplitude A1 square plus A2 square plus 2 A1 square A2 square A1 A2 cos 5. A1 square plus A2 square plus 2 A1 A2 cos 5. And angular position, that is sin theta equals lambda by d. Angular position sin theta equals lambda by d. And fringe width, it is beta equals lambda d by d. And the next one is fringe width, beta equals lambda d by d. And xn for bright fringe, xn equals n lambda d divided by d. And the dark fringe, xn equals 2n minus 1 lambda d divided by 2d. And the next one is last formula, mu minus lateral shift mu minus 1 mu minus 1 t d divided by d. So these are all the important formulas what we have discussed in wave optics chapter and interference. So next class we discussed some important previous year problems. So on the basis of these formulas, is it clear? So now keep in mind, don't neglect all these formulas. Is it clear? Okay, next class we'll discuss about important problems. Thank you all of you.